Bismillahirrahmanirrahim. Today I'd like to elaborate on the material that we learned last time. If you recall, a plane is a two-dimensional figure. It's kind of like a paper that goes on in all directions infinitely. It's an infinitely long paper that goes on forever in all directions. So if you imagine this to be like a notebook paper, that is, those are the three holes in the notebook paper like that, and you would write here like this. So that's kind of like a plane, but the only difference is it goes on forever. Now imagine if some young man or some student were to draw a line on this piece of paper. Here's a line. So they drew this line on the piece of paper like this. Now this line would be inked or drawn on the piece of paper, and we say that this line is on the plane. So we can call this line line L, and we say line L is on the plane. We can also have points in the paper. Let's say if the student took a pen or pencil and they put different points in the paper like this. Those points would be said to be on the plane. Now, if, for example, there's a point over here that's not on the plane, that's like, let's say on the sky, that's not on the paper, we say that point is not on the plane, or that point is not in the plane. So point A, B, and C and line L, they lie on the plane, and they are on the plane, whereas point D over here is not. We also learned last time two separate ways of naming a plane. So one way was that to pick 3 points that are not collinear. So I have, let's say, 2 points here. Let's call this point A, point B, and point C. And these 3 points altogether are not collinear, that they are not on the same line. And so we can call this plane A, B, C. That's one way of naming a plane. Another way of naming a plane would be to simply call it by its own name, plane K. So we use a capital letter and to denote the name of a plane. So that's plane K. Or sometimes you can use, Greek letters, foreign letters, not English language letters, and call it by those names, such as, for example, plane pi. So you could call this plane, if you wanted to, plane pi like this, because it's so different from everything else. But typically we use capital letters to also name planes. Now this K here is not a point on the plane. So that's the second way of naming a plane. I cautioned you last time that when naming a plane, you have to make sure that the points are not collinear. So if we had a point, let's say over here, let's call this one N over here, you can't say that this is a plane A and B. This would not be a proper naming of a plane. So the points that are used to name a plane, they cannot be collinear. The reason for that is that you can have multiple planes that can be named by 3 points that are on the same line. For example, here I have 2 intersecting planes. Now they're named plane P and plane Q. It possibly would be proper to use a capital letter here. So plane P and plane Q, or perhaps they're using a Greek alphabet, whatever. But as you can see, then 2 planes meet, they intersect in a line. So they meet in a line. So if you take 2 pieces of paper and one were to go through the other one, the intersection would be a line like this. In this case, it's line M. And you can imagine if you were to pick 3 points over here that are on the line, okay, and you say, okay, that's plane, okay, let's call this one ABC, and you call that plane ABC. Well, both of these 2 planes, the blue plane and the red plane, they both have those 3 points in them, right? Because this line is common to both of those planes. So you cannot use 3 collinear points to name a plane. In fact, you can have multiple planes that can go through these, or infinite planes, in fact, that can go through these same points. So the points used to name planes, they have to be non-collinear. Consider this, for example. Here we have 3 planes. There's a red plane, the green plane, and the blue plane, and they all intersect at through one line right here, and that's over here. So the point of intersection is still one line, right? And then, so imagine 3 points on that line, and it's called ABC. Then if you say plane ABC, which plane are you talking about? Because that line is contained, that line is part of all three planes. Okay? So you cannot use three collinear points to name a plane. They have to be non-collinear. So A, C, B would be for this particular plane. A, C, B would be okay, or C and B would be okay, etc. So there are multiple combinations, but the points have to be non-collinear. This, in fact, introduces us to a very important concept, and that is the following: 3 points, not three, 3 points. Okay, 3 points. Okay, determine a plane. Okay, this is very important to understand. That is, we have to be again careful here and remind ourselves that 3 points that are non-collinear. So it's assumed over here that 3 non-collinear points determine a plane. That is, if you have 3 points, any 3 points, okay, and there's only one plane that goes through these 3 points. If you were to imagine, if you connect these, and then it's like a triangle, and then if you expand them in all directions, right, it's like a ink would flow, right? There's only one plane that would contain those 3 points. So there's only one unique plane that would have all these 3 points. Previously, if you recall, we learned that 2 points determine a line. 2 points determine, determine, determine a line. That is, if you're given any 2 points, there's only one line that goes through them. There's only one line that goes through these 2 points. Can you give me another line that goes through those 2 points? No, there's only one line. In the same way, if you're given 3 non-collinear points, 3 points determine a plane. Okay? In fact, it is for this precise reasons that tripods are used for cameras, etc., because they have 3 points at the ends over here, and there's only one plane that goes through those 3 points, so they will always be stable, and that's why tripods are always stable. They don't shake and move, because 3 points determine the plane, and they'll find the plane of the ground and stay there, and that they won't wobble because there's only 3 points, and they'll always find the plane that they are in. So tripods are used for this particular reason, because in fact 3 points indeed do determine a plane. Just like 2 points determine a line, it's assumed in this particular statement that 3 non-collinear points determine a plane. Okay, now observe some lines for a minute. So we have a line over here. There's no plane here yet. So we have a line here. Let's call this line L. And then I'm going to draw another line, and this is line over here, and let's call this one line M. Now these are 2 lines that intersect. In fact, they intersect at this point right there. So lines can of course intersect, and the point of intersection here, let's call this one point P. So line L and M, notice I used lowercase letters to name these lines. They intersect, and they intersect at point P. Now lines can intersect in many different ways. So here's a line I've drawn, and I'm going to draw a second line over here like this. And these 2 lines intersect in a perpendicular angle like this. In fact, when 2 lines intersect like this and in the perpendicular line, all 4 angles are actually going to be 90 degrees, isn't it? Because these are going to be supplementary, right? And so when 2 lines intersect, they in fact create 4 90-degree angles. Now lines don't have to intersect, right? Because you can have 2 parallel lines. So here's a line, and here's a second line, and these lines never intersect because they are parallel. In geometry, if you want to denote 2 lines that are parallel, we give them similar symbols like this, typically like greater than or equal to symbols, like that, and these symbols tell us that these 2 lines are parallel. So lines that are tick marked in a very similar fashion like this are known to be parallel. Now you don't use tick marks like this, like the congruent tick marks like that, okay? So that doesn't make any sense. But so you use one tick mark like this to suggest these two lines were parallel, or two tick marks like this to make sure everybody sees that that you made tick marks and those two lines are parallel. So lines can intersect in one point, they can intersect like this, and they can also be parallel. In fact, one line can be right on top of another line. That is, two lines can be right on top of each other like this. So unless we're told this could be line L, and the line behind it, the white line, could be line L. So these are two lines that are right on top of each other, and that's a possibility. Right? So two lines could be the same line, right? So, but anyways, that's less common scenario, of course. But when we're talking about lines, they either intersect in one point, or they are parallel. But if they're the same line, then their intersection is like the whole line. Every single point is common to the other one. So this is intersections of line. Now, lines can also be intersected with segments, etc. So here I have a line, right? And I have a segment that I'm going to draw over here. Here it is. It starts there and ends here. Segment has two endpoints. Let's call this A, and let's call this B. And we can name this line. Let's call this C, and let's not go fancy. Let's call this D. So segment AB intersects. Okay, so it intersects line CD. See how we denote line CD. And let's say if it intersects here at this point, okay, at point E. So when two lines intersect, they intersect at a point. Next, I want to talk a little bit about how lines may intersect. I have redrawn a plane over here. Now, this particular line L over here, was in the plane. That is, it was on this piece of paper, if you can imagine. But there could be a line that is not in the plane. Now, if you can imagine a pencil just going through and through, poking a hole in the plane. So if you can imagine a pencil going through a plane, like poking a hole to it, that would be a line that is going through a plane. So if I were to draw this, kind of like this, and imagine that's like a poke, and then you won't be able to see the rest of the line, okay? You know what I'm saying? So it'd be like this over here, and you won't see the line until it comes out over here, you know what I'm saying? So if I were to draw this line like this, to suggest that it's going through the plane, I do one of these. So I first draw the line over here, and I take my eraser, and first, let me put it like this. So if this line intersects or goes through the plane at that point, and this part of the line, see, this part of the line you can't see because it's behind the paper until it comes out over here, and then you can see it again. So this is a line. Let's call this line, let's give this line a name. Let's call this line M. So line M goes through the paper like a pencil goes through the paper, and it intersects the plane right at this point. Let's give these planes a name. This is a plane K, and this point of intersection right here, let's call this one point L. So line M intersects the plane K at this particular point L. Okay? Now, there could be another line that goes through the same particular point intersecting the plane like this. So here's a different line. It's like another different pencil that's also kind of like poking through the same point. Oops, that's not quite right. It's kind of poking through the same point like this, but going straight up and down. And this part of the line, again, would be behind the paper, kind of like this. Okay, you won't be able to see it. I'm making it dotted so you can't. And then when it comes out over here, you can see it again. Okay, so this is line, let's call this one line N. We're using lowercase letters to name those lines. Okay, so we have two lines that are going through the same point. So, and you can see over here line M and line N, they intersect. They intersect each other. So one is going this way, one is going that way. They meet, and their point of intersection is point L, right? So the line N and line M and N, they intersect. We say they intersect. They meet, and they intersect at point L. So line M and N, they intersect at point L. Okay. Now, a line could be intersecting the plane and does not have to be at the same point. Let me try to draw this one. Here's another line that's going through over here. Okay. So there's another line that's going through the plane. All right, like this, but it's not intersecting at that point. But it's intersecting the plane right over here. Okay. So this part of the line you can't see because it's behind the plane until it comes out over here. Okay, so now this line we can give it a name. Let's give that line a name, and let's give that name using points. Okay, let's call this one F and G. So this is line FG. So line FG intersects the plane at point H. So line FG, that's line FG, intersects the plane at point H. Okay, and as you can see, it doesn't intersect any of those lines, right? So which is very interesting. So these are different scenarios of how lines can be in a plane. Now here we had this particular line, line L. All right, so line L was on the plane. Let's draw that line over here like this. So here's line L. Okay, now that line does not intersect, does it? Does not intersect any of these lines, because line M is not, it's not in the plane. Line M is not in the plane. It's doing one of these. It's going. It's like a pencil poking through the plane. Okay, whereas line L here is on the plane. Okay, so these are all different scenarios where lines and planes can intersect. So line L is in the plane. You can say line L is in or on, is in plane K. That is, it's like a pencil sitting on top of a paper, just resting on top of a paper. So line L is on the plane K or in the plane K, whereas the other lines that have drawn over here, the blue and the white and the purple ones, the line M and line FG, they are intersecting the plane. They're kind of like pencils going through the plane from different directions. Now line M and N, they go to the same point, the same hole in the paper, whereas this other line goes to a different point in the paper. Okay, so these are possible ways that lines and planes can intersect. Next, I'd like to talk about intersecting planes. Okay, so these can be a little bit tricky, but if you can follow me, what I'm going to do is I'm first going to draw, maybe I'll just draw a nice big plane over here like this, okay, to make sure that it is clear. Now, drawing planes can be a little bit tricky, and it tends to be harder for students because you're trying to draw like a three-dimensional picture, right? So this is like a parallelogram type of thing, but it's supposed to represent a flat plane, like a piece of paper. So you're looking from like a side view, right? So this is a plane. Now, do planes have to intersect, right? No, you can have two planes that never intersect, okay? So I can have two planes that are parallel. So here's a plane. Now this plane is supposed to be like on top of a plane, like the two ends of a book. So if you have a book, right, you can have a book like this, right? Right, and then here's the two covers, right? And then here's the pages of the book, right? So the front cover and the back cover, they never meet because they're like parallel planes, right? So two planes, they don't have to meet. So planes can be parallel. So let's label these planes, and we can say this is plane K and this is plane L, and we say plane L and plane K are parallel planes. They never intersect. Okay, that's cool. But then planes can also intersect each other. It's like two pieces of paper, one going through and through the other one. So I'm going to try to draw that, and that's kind of tricky for some students, as I said. So just try to imagine this. So the way I do this is I start somewhere like over here. Try to pick an angle that it's going to be intersecting like this, and then I'm going to draw like this. And I have to actually draw this line a little longer, like this. It didn't quite work out, so you can tell it's not easy, right? So you have to draw it like this. Alright, and then I have to make this one longer a little bit. Alright, and then I have to try to make this end to be kind of parallel to the other end to make it realistic. So I have to erase this part, a big eraser, so I'm going to erase this part. Now, to make it look realistic, that is, to make it look like these two planes are actually crossing each other, you have to do a little bit of artistic work, okay? So now this part of the blue plane you can't actually see because it's behind the other planes, okay? And this part of the white plane you can't see because it's behind the blue plane, like that. So you have to kind of make these artistic adjustments to suggest that these are two intersecting planes. The key thing to realize here, though, is when two planes intersect, their intersection is a line. See, when two lines intersect, their intersection is a point. But when two planes intersect, their intersection is a line. Let's call this line M, like this. So when two planes intersect, their intersection is a line. Here we have two planes. See, this is like a three-dimensional picture. This is a blue plane. Let's call that one plane B for blue. Maybe I could use even a blue letter to label it. So this is plane B for blue. Maybe that's not the best idea. So this is plane B for blue, and this is, let's call this one plane M here, okay? Or plane, I don't know, Z. Let's call that plane Z. So blue plane and this brown plane. The point of intersection, the way they intersect each other, when two planes intersect, they create a line. Their intersection is this particular line over here. Okay, now the planes go on forever, right? So this line will also go on forever because these are infinite planes. So this is, let's call this one line M. So the intersection of two planes is a line, and this is important because this is the reason why we don't use points that are on the same line to name a plane. So when you're naming planes using point, if you recall, they have to be non-collinear, because let's say these 3 points, okay, let's call this point A, point B, and point C. These are on line M. Now this line M is laying on plane B, but it's also part of plane Z, isn't it? So the intersection, so this line is common to both of these planes. So that's why you can't use 3 points that are collinear to name a plane, because many planes can in fact go through this particular line. Okay, if you can imagine this plane swiveling, like rocking back and forth, you can imagine infinite number of planes that can go through the same 3 points. Okay, so now let's explore this particular picture here. So now we have 2 planes that are intersecting each other, and their intersection is a line. Now I can draw this line over here. Okay, here's a line I'm going to draw, and I can even draw a ray. Why not? So let's draw a ray. So here's a ray that starts from here. Let's call this point A. Let's not try to be too fancy. Now this ray AB, now let's call this AC to avoid confusion here. Ray AC lies in plane B. So the ray AC, okay, so this particular ray lies in plane is on plane B. So it's on plane B. Okay, so it's kind of coming out like this. Now I can draw another ray, and that's on plane Z, straight up like this. Okay, plane Z like this. All right, so let's call this one D. That point is D. So AD, ray AD, is in plane Z. So it's part of plane Z. So it's going straight up. If it's going straight up, right, and this one is going like this, okay, it's possible that this could be like a 90-degree angle. And it's 90-degree angle, only these 2 planes are like perpendicular to each other, right? So assuming that these planes are perpendicular to each other, you can have like a straight angle created over there. Now I made a ray over here, but I didn't have to make a ray. I could have made a line, right? So let's make a line that's going through those 2 points. Let's see. So I'm going to turn this ray into a line like this. Okay, like this. All right. So now it's a little trickier because I have to try to somehow suggest that this line is on Z. Okay. So let me show you how one would do that. So I'm going to draw a line. It's kind of tricky, so I have to do it like in two parts, like this. So this line is going to be in Z. Okay. So if it is in Z, well, I won't be able to see this part of it because it's kind of like behind the blue plane. I will be only able to see the line again when it comes out, like over here. Okay, so as I said, it can be tricky because it requires a little bit of artistic skill to see this and to be able to draw these things. Okay, here's a line that's in plane B. Okay, here's a line that's in plane B. Let's call this one line N. Okay, now this line is in plane B, so you can't see this part of it because it's going to be hidden by plane Z. Now if this line N is parallel to line M over here, if line N is parallel to line, it will never intersect plane Z. Okay, so it will never intersect plane Z. So in fact, a line does not necessarily have to intersect the plane because a line can also be parallel to a plane. Okay, so here we talked about two intersecting planes. And I also suggested to you that planes don't have to intersect. Now let's also explore what else can happen with planes. Alright, so now observe this. Now we have two yellow planes here. We can call that plane P and plane L. And let's call this plane K. Okay, so we have two planes, plane P and plane L, that are in fact parallel to each other. They never meet. And then there's plane K that kind of goes slanted, so, and then it intersects the other two planes. And wherever it intersects, of course, it creates a line, right? So there are two lines over here that are intersecting. So even though it looks like a segment, these are planes, so they go on forever, right? So these are like lines that kind of go on forever, like this. I didn't draw the best over here. So here's one line over here that goes on forever, and then there's this other line here that goes on forever too, because that's a line that going on forever. Now if these two planes are parallel, these lines will also be parallel. Those lines will never meet, right? Those are the intersection of plane K and those two lines. So this is another possibility of how planes can meet. Drawn over here is actually like a cube, or actually a rectangular prism to be precise, but it's kind of like your room. If you're sitting in a room right now, this is a cartoon representation of that. In fact, the roof of your room and the floor of the room are two planes, aren't they? So there are two parallel planes. If the roof is like this and the floor is like this, there are two parallel planes that never meet, theoretically, correct? And then the sides of the rooms over here, the sides of the rooms are also planes, but they meet. So this top plane over here, if you say this green plane over here like this, and this front plane over here like this, all right, those two planes, the top plane and the front plane, they would meet, and their intersection would be what? What would be the intersection of those two planes? If you say it's this line, that would be correct. So the intersection of the roof and this particular side wall here would be intersection of the roof, and this particular side wall, the front side wall, would be that particular line. Okay, the intersection of this side wall and this front side wall, the intersection of these two side walls would be this particular line over here, right? So this line is the intersection of this plane and the front plane, all right? In fact, the corner of the rooms, let's say the top corner over here, so the corner of the room over here, let's say this corner right there, so that corner represents the intersection of this plane and this plane and this plane. So when the three planes meet, they intersect at this particular point. So if you look at, if your roof, assuming your room is kind of like this shaped, if you look at any corner of the room, you will notice that there are three planes, in fact, that are intersecting. So three planes can intersect like this, and they would give a presentation something like this. In summary, this picture over here summarizes some possibilities of what planes can do. Here we have three planes that are parallel and they never meet each other. And this scenario, we have two planes that are parallel and one plane, the green plane, that cuts through them. That's that particular scenario again. And this over here are three planes that intersect in the same line. So three planes that intersect in the same line. So if you were to have another plane going through this particular line, so that would be that particular scenario. Multiple planes can go through the same line of intersection, right? And this scenario is where three planes intersect separately. So this one goes there, that one goes there, this one goes there. They're all kind of like intersecting each other. Okay, and this particular last scenario is very, very special because they're all perpendicular to each other. And that's kind of like this scenario. See, this wall is perpendicular to this wall, and that's perpendicular to the floor and the roof. So they're all perpendicular to each other. And the interesting thing about that is wherever three planes meet, the roof here and the side here and the front wall over here, or this side wall here, this side wall, and the floor over here, wherever three planes meet, let's say the roof and the front wall and the side over here, wherever the three planes meet, the point of intersection is actually a single point. There's only one point that's common to all three of them. And then you have to kind of think about this, make sure you convince yourself. In this particular picture, that's that point right there. And that point is common to all three of those planes. Now, definitely, when planes intersect, they intersect in a line. So this line, for example, this edge here, is the intersection of this plane and this plane. All right, so, but the intersection of three planes is a single point. So today we talked about a lot. We talked about lines intersecting, we talked about planes intersecting, and we talked about multiple planes intersecting. Indeed, we did cover a lot of material. I hope you appreciate this, and we shall build on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.